Good morning, students. Today we will be talking about acids, bases, and salts. First of all, we need to know what is ionic equilibrium. So you can simply take the simple definition: equilibrium involving ions in aqueous solution. This is termed as ionic equilibrium. Acids, bases, and salts come under the category of electrolytes and may act as either strong or weak electrolyte. There are two types of electrolyte basically: strong electrolyte, weak electrolyte. Strong electrolyte, you can say, which dissociate more than 95%, and weak electrolyte, they generally dissociate up to 5 to 10% only. So today we'll just talk about acids, what are bases, and what are salts. Different definitions given by different chemists. You understand this? Hydrochloric acid present in the gastric juice is secreted by the lining of our stomach in a significant amount. Like you can say this amount is 1.2 to 1.5 liter per day, and it is essential for the digestive process. Similarly, acetic acid is known to be the main constituent of vinegar. So what is acetic acid? This is CH3COOH. Acetic acid is nothing, simply ethanoic acid, CH3COOH. You can make its expanded structure also: CH3, C double bond OH. Now lemon and orange juices contain citric and ascorbic acids, and tartaric acid is found in the tamarind paste. So these you can say these are the applications like where we are using different kinds of acids. As most of the acids taste sour, generally acids taste sour. The word acid has been derived from a Latin word acidus, meaning sour. Maximum words are derived from Latin or Greek, I guess. Acids are known to turn blue litmus paper into red, and they liberate dihydrogen on reacting with some metals. This you know from your class 10th. So I just use acronym like A, B, R. A for acid, blue to red. Their taste is acid's taste is ATS. Acid's taste, S stands for sour. What about base? Base turns red litmus paper into blue, and their taste is BTB, bitter. Okay, this is how you can relate things. Similarly, bases are known to turn red litmus paper blue, taste bitter, and feel soapy. This you know from your class 10th. As we are switching topic, so let me change color. Mm, just give me a second. Sorry for the inconvenience. So bases are known to turn red litmus paper into blue. They taste bitter and they are soapy. When you try to touch them, you will feel kind of soapy. A common example of a base is washing soda used for washing purposes. And we know the neutralization reaction. And what was this? From our earlier classes, we know this is nothing. This is very much simple. Acid plus base, we will get salt plus water. And this reaction is termed as neutralization reaction. Okay, this is neutralization reaction. Okay. This color does not go that much. Let me. When acids and bases are mixed in a right proportion, they react with each other to give salts and water. There are some commonly known examples of salts are, you can say, sodium chloride, NaCl, barium sulfate, BSO4, sodium nitrate, NaNO3, sodium chloride, common salt, uh, is an important component of the our diet, and it is formed by the reaction between hydrochloric acid and sodium hydroxide. So just take a look how this is going to happen, how you can remember things. What is the formula for sodium chloride? This is NaCl. But how this is formed? We will be using an acid and a base. Base is sodium hydroxide, NaOH plus HCl. Hydrochloric acid, just do something like this. What is this? H2O. So we are getting water plus these two part will join together and you will get NaCl, and this is our sodium chloride, or you can say sodium salt, or you can say common salt of sodium and chlorine. Na positive, Cl negative, you can sometimes write it as if you are considering ionic charges. Okay, there can be another examples like BSO4 and sodium nitrate NaNO3. Okay, now what next? Sodium hydroxide, sodium chloride. Okay, it exists in solid state. Talking about sodium chloride. NaCl state is solid state as a cluster of positively charged sodium ions and negatively charged chloride ions, which are held together due to the electrostatic interactions between the oppositely charged species. You can see the pictures given below. Because we are having two types of charges, positive as well as negative, so there will be force of attraction between the ions. The electrostatic force between the two charges are inversely proportional to the dielectric constant of medium. This you will come to know about in class 12th, well, when you will be studying electrostatic, electric field, elect coulombic force. So this you can relate like if F is the force, if F is the force between these two particles, this is 1 over K. K is dielectric constant and value for water is round of 80. Water, a universal solvent, possesses a very high dielectric constant of 80. Water is a universal solvent because it is available everywhere. Thus, when sodium chloride is dissolved in water, the electrostatic interaction are reduced by a factor of 80. So the force will become 1 over 80 and the ions, and this facilitates the ions to move freely in the solution. Also, they are well separated due to the hydration with water molecules. So this is represented in the picture as shown below. Dissolution of sodium chloride in water, we are having Na positive ions, Cl negative ions stabilized by their hydration with polar water molecules. Why water is polar? Because this is H positive, OH negative. So when two charges are separated by some distance, we will have a dipole moment, that is Q into distance between the two ions. Comparing the ionization of hydrochloric acid with that of acetic acid and water, we find that though both of them are polar covalent molecules, former is completely ionized into its constituent ions, while later is only partially ionized, less than 5%. So this is like how many ions you gonna get. The extent to which the ionization occur depend upon the strength of the bond and the extent of the solvation of the ions. So there are two factors which give information about the extent to which ionization occur. This is important. Former is completely ionized by the constituent ion, while second one is just partially ionized, less than 5%. Here we are talking about former means former is HCl, and later we are using acetic acid, because why HCl is completely ionized, because it is a strong acid, or acetic acid, this is a weak acid. The term dissociation and ionization have earlier been used with different meaning. Dissociation refer to, this is the definition for dissociation. It refers to the process of separation of ions in water, already existing as such in the solid state of the solute, as in sodium chloride. Solute is that part of solution which is present in lesser amount. On the other hand, ionization corresponds to a process in which a neutral molecule splits into charged ion in the solution. Ionization corresponds to a process in which a neutral molecule splits into the charged ions in a solution. So we shall not distinguish between the two and use the two terms interchangeably in this chapter. So first let us define what is a acid, what is a base. First time Arrhenius try to define this. So you can say this is Arrhenius concept of acids and bases. And what is this? This is the simple definition by Arrhenius. This is very basic definition. Acids are substances that dissociate in water to give hydrogen ion H positive, and bases are substances that produce hydroxyl ion OH negative ions. This is simple definition given by Arrhenius. So you can see in below reaction, the definition of an acid HX is H positive aqueous and plus X negative aqueous. This H positive sometimes adds with water molecule. So we are having H3O positive. This is hydronium ion. A bare proton H positive is very reactive and cannot exist freely in the aqueous solution. Thus, it bonds to the oxygen atom of a solvent water molecule to give trigonal pyramidal hydronium ion H3O positive. See the box given side by side. So you can remember hydronium ion is H3O positive and its shape is trigonal pyramidal. We shall use H positive and H3O positive interchangeably to mean the same, that is a hydrated proton. Similarly, a base molecule like MOH ionize in aqueous solution according to the equation MOH aqueous gives you M positive aqueous OH negative. Now we are having OH negative, so this is a base. The hydroxyl ion also exists in the hydrated form in the aqueous solution. So this is simple definition by Arrhenius. कोई भी चीज अगर आपको H पॉजिटिव देती है तो Arrhenius के अकॉर्डिंग एसिड है, कोई भी चीज अगर आपको OH नेगेटिव देती है तो Arrhenius के अकॉर्डिंग वो बेस है. Arrhenius concept of acid and base however suffers from the limitations of being applicable only to aqueous solutions and also does not account for the basicity of substance like ammonia. You know, ammonia is NH3. Ask someone. NH3, ammonia. Okay. Now, if you see this, you are not able to tell is it a acid, is it a base. So, Arrhenius concept fail here, which do not possess a OH negative group, hydroxyl group. But this is a base. Ammonia is a base. So that's why this Arrhenius concept is having some limitations. So a new concept came into the existence. This you can mark. This is basically the limitation of Arrhenius concept. So this is not a full concept explained accurately and precisely by Arrhenius. So we need some further modifications. Hydronium and hydroxyl ions. Hydronium ion, hydrogen ion by itself is a bare proton with very small size, that is 10 to the power minus 15 meter radius, and intense electric field, binds itself with the water molecule at one of the two available lone pair on it, giving hydronium ion. So this is shown below, like this is, you can see this one is S3 O positive. This species has been detected in many compounds. For example, S3 positive, S3O positive, Cl negative in the solid state. In aqueous solution, the hydrogen ion is further hydrated to give. You can add one more water molecule, you will get H5O2 positive. Then you can add one more H2O molecule, H7O3 positive, and H9O4 positive. Similarly, hydroxyl ion is hydrated to give several ionic species like you can add water OH negative, then H3O2 negative, then H5O3 negative, and then H7O4 negative, and so on. Let's talk about second concept, and that concept was given by Bronsted-Lowry, acids and bases concept. So Lowry gave a simple definition, and that simple definition is Bronsted-Lowry concept is this only. Acid is a substance that is capable of donating a hydrogen ion. Bases are substance that are capable of accepting a hydrogen ion. अगर कोई H पॉजिटिव दे रहा है तो वो एसिड है, और कोई H पॉजिटिव ले रहा है तो वो बेस है. In short, you can say acids are proton donor, bases are proton acceptors. Now you can see this in example. Consider the example of dissolution of ammonia in water. Represented by this ammonia NH3 plus water. Add one proton from water to NH3. We will getting conjugate acid NH4 positive hydronium ion and OH negative conjugate base. Now this is very much important. You Here you will learn about how you can make conjugate acid and base. Like look here, this ammonia is base So when proton is added from water to this become NH4 positive ammonium ion. So for base, we will be having conjugate acid on the right hand side. For acid, because proton is gone, so what is left? Only OH negative is left. So this is a conjugate base. बेस का राइट हैंड साइड कॉन्जुगेट एसिड होगा, एसिड का राइट हैंड साइड में कॉन्जुगेट बेस होगा. सिंपल कॉन्सेप्ट. द बेसिक सॉल्यूशन इज फॉर्म ड्यू टू द प्रेजेंस ऑफ हाइड्रोक्सिल आयन. अब हमें पता है कि ये जो सॉल्यूशन होगा, दिस इज अ रिवर्सिबल रिएक्शन एज शोन बाय द डबल एरोस. So solution will be basic because we are having OH negative ions. In this reaction, water act as a proton donor and ammonia molecule act as a proton acceptor. So they are Lowry-Bronsted acids and base. In reverse reaction, H positive is transferred from ammonium NH4 positive to H negative. In this case, NH4 positive act as a Bronsted acid while OH negative acted as a Bronsted base. So acid base pair that differs only by one proton, that is known as conjugate acid base pair. So sometimes this is asked, what is a conjugate acid base pair? This you can highlight in your book. Therefore, OH negative is called the conjugate base of acid water. वाटर है, अगर आपको आप वाटर को एज एसिड ट्रीट कर रहे हैं, उसमें से प्रोटॉन निकाल दीजिए, तो जो बचेगा दैट विल बी conjugate बेस. अमोनिया है, अमोनियम आयन NH4 पॉजिटिव, क्या करना, इसमें से H पॉजिटिव निकाल दीजिए. तो दिस इज conjugate acid of base ammonia. Ammonium is conjugate acid of base ammonia. यहाँ पे इंपॉर्टेंट कॉन्सेप्ट है, आपको सीखना है conjugate acid और base के बारे में. So let me highlight this also so that you get. If Bronsted acid is a strong acid, then जो conjugate base बनेगा that will be a weak base. और अगर Bronsted acid weak acid है, तो जो उसका conjugate base बनेगा वो क्या हो जाएगा, strong हो जाएगा. ठीक है, तो ये लाइन भी इम्पोर्टेंट है. हम थोड़ा रेड से शो करते हैं एंड वाइस वर्सा. It may be noted that conjugate acid has one extra proton and each conjugate base has one less proton. So, if we are talking about conjugate acid, we will have one extra proton, conjugate base, one less proton. See one more example explained. This is the example of ionization of hydrochloric acid in water. So let me try to explain. ये हमारा एसिड HCl, वाटर यहाँ पे काम कर रहा है बेस वाला. अगर मैंने इसमें H पॉजिटिव ऐड कर दिया है, यहाँ से H पॉजिटिव गया इसके अंदर, तो ये क्या बन गया, H3O पॉजिटिव बन गया. तो बेस में ऐड हुआ था प्रोटॉन, तो क्या बन गया, कॉन्जुगेट एसिड, और इसने लूज किया अपना प्रोटोन, तो ये क्या बन जाएगा, कॉन्जुगेट बेस। अब यहाँ पे ध्यान रखना है, हमें पता ही क्या है, इसका नेचर था स्ट्रॉन्ग एसिड, तो ये जो बनेगा ये क्या बनेगा, वीक बनेगा। ठीक है, दिस इज इम्पोर्टेंट, यही एक्सप्लेन कर रखा होगा नीचे, अगर ध्यान से पढ़ेंगे तो। It can be seen in the above equation that water acts as a base because it accepts the proton. The species H3O positive is produced when water accepts a proton from the HCl. Therefore, Cl negative is the conjugate base of HCl and HCl is the conjugate acid of base Cl negative. Similarly, this is just like how you can write the above equation in words. Similarly, H2O is conjugate base of an acid H3O positive and H3O positive is the conjugate acid of the base H2O. Then you know that ड्यूल रोल ऑफ वाटर, हाँ ये लाइन भी बहुत इंपॉर्टेंट है, वाटर का भी ड्यूल रोल होता है, इट कैन एक्ट एज एसिड as well as a base depending upon the with which water is going to react. In case of reaction with HCl, HCl strong है, so water बन गया base, लेकिन अगर हम अमोनिया यूज कर रहे हैं, it act as a acid by donating a proton. Okay, so try this problem 7.12. You will 7.13 about conjugate acid base, and you will master this concept basically. Okay, now this Bronsted concept is also having few limitations. You will know when you practice few questions on this topic. So this is sufficient for the day. In between, this is written about Arrhenius, and maybe this is about Michael Faraday. Okay, so this we need not to consider. So today just read 7.10 acids, bases and salts completely, and then you just read 7.10.1 Arrhenius concept, and then you read 7.10.2 Bronsted Lowry acid and base concept. Okay, so this is enough for the day. Next class we will discuss about Lewis acids and bases.